That's great. So, again, my name is Masood Parvania. So today I'm going to talk about a little bit about like resilience, the topic of resilience, which is the grid resilience, which includes, of course, like resilience against extreme weather events, but also resilience towards long-term changes that is happening on the grid, including the change in the generation mix, plus like the integration of new types of loads and resources on the grid. So specifically, I'm representing and I'm the director of this new NSF center that we just established in the University of Utah last year. It's called US-Canada Center on Climate Resilient Western Interconnection, or NSF Wired Global Center. This was funded as part of NSF Global Center program, the competition that NSF ran last year. They only funded 7 of it. We were one of them. NSF was response to this NSF Global Center program. NSF was looking to establish centers around energy and climate, that very broad topic internationally between US, UK, Canada, and Australia. So it made sense for us to propose something with Canada because we share the Western grid, which is called the Western Interconnection with Canada. And we have the same problem. They are dealing with extreme weather events. We deal with the extreme events and also impact on the grid. And we are working on the same problem. We have the same expertise, but working across the border. So it made sense for us to bring this together. Working together, we have 11 universities. This is co-funded by NSF and NSEC in Canada. You see some of the academic 11 universities, but also we have a lot of power utilities in the West, plus some government agencies, including WEC, and also US Forest Services, FEMA, and some of the other agencies that are working with us. So what we do, we look at the 4 major activities here: use-inspired research, climate and grid data infrastructure, community engagement, and innovation. We are developing an innovation ecosystem for commercializing the resilience technologies we are developing. Okay, so this is, oh yeah, movie. So extreme weather events, it's not climate change. So we are not we are not talking about climate is changing or not. As long as things are happening, as long as we have heat waves, as long as we have hurricanes, as long as we have storms, we just need to make sure that grid is resisting and is withstanding some of those and being able to power the communities as it has done in the past many years, right? So it's not about we are not advocating for changing climate, but we just want to make sure as long as the extreme weather happens, we are securing the grid against this. The grid is resilient against it. So these are the maps that are past. These are not future forecasts. These are the maps of things happening. As you see, things happening in the West are different from things happening in the South and in in Texas. But we are all dealing with similar things, right? So there are problems here on the on the climate side, on the weather side, and whenever it happens, whenever anything happens, the first thing it impacts, the grid is on the news, right? So the grid is on the news, and we are hearing about the fact that this many people don't have the power. So we just need to make sure that as long as things keep happening, we are making the grid resilient against that. In the West, the problem is different. We don't get hurricanes. We get a lot of wildfires, and we get heat waves. Specifically, heat wave is something that is has been in in the center of attention the past 5 years, since 2020 almost. The first one, the first graph here, kind of the map here showing the map of the Western US in 2020 August, and down there it's showing the kind of the same on another day, September 2022. So what's happening, you see that almost all major cities on the West are above 100 degrees on a given day. And it's not just one day, a few days before this, few days after that, that was the case over there. So what's happening is that this is putting a lot of pressure on the grid. So grid is not built to, a grid of the West, it's not built to tolerate this much of heat all over, all over the West, and for a longer period of time. So what's happening is that this was very eye-opening for the grid. We call it silent killer. It's not impacting the grid immediately like hurricane that is like putting down the whole grid, but it's like impacting and putting a strain on the grid. Specifically, you see that these are some metrics that are published by Western Electricity Coordinating Council that are showing like how the grid is impacted in terms of the number of like interruption and the duration of interruption in those specific 2 quarters that I just mentioned, 2020 and 2022. As you see, like just because of heat wave, there was nothing else happening. Like you see a lot of like increase in the like number of like outages and like frequency of outages. So we just need to work on that, right? That's one of the problems we are working on in the center. But the way we are looking at it, we are taking a data-driven approach. We are not just like stipulating the future. We are looking at a lot of data. One of the things we are developing in the center, we call it weather and grid data cyber infrastructure. One of the challenges when it comes to like studying the like extreme weather events and their impact on the energy to power grid is that we need data. We need high quality data, and it turns out there's a lot of data. But the weather data are some of the like largest data you can imagine. But one of the challenges is that how like engineers who don't necessarily use those data in everyday kind of like type of practices we do. In our studies. So we developed this like a cyber infrastructure that is shared between the institution across the West to be able to share easily the data that we all have access to and we measure. In addition to this infrastructure that we have created, we are bringing a lot of data to that, raw data to that. So like this map is showing like these dots here are showing like more than 35,000 weather stations that we have access to across the Western US. And those are just like the raw data that we bring to the center to do the analysis and the forecast. But in addition to that, we have like a post-analysis that is very common in like climate science. And those are like the data that are post-processed, the raw data that are post-processed, and like to make sense out of them, like in terms of like how much they deviate, for example, from from the norms. That map in like that map here shows like one specific week back in June this year that shows that like weather in the West was so hot that it was more than like at some point it was more than like 10 to 15 degree above average in an early week in June. So that shows that like we are getting some of this like hot weather earlier in the year, and like that is taking like longer and like impacting a large geographic area. And that's that is done by some of our partners in Desert Research Institute at the University of Nevada. And then we are also, in addition to that, we are also working at wildfire and the smoke out of the wildfire. We have like a wealth of data that shows how wildfires are generated and how they are impacting the environment in terms of the smoke transfer and then how they are impacting the power grid. So one of the things that we have access to is like some of our partners in University of British Columbia. They are well known like globally for the like wildfire model and wildfire forecast that they are generating, plus the smoke model and the smoke forecast that they are generating. But they were like their funding was limited to the work that they do in Canada. Since opening this center, we have enabled to bring some of those models that are some of the best models in the world to the US and to the Western US, and now they are doing like this globally. This is like this is ironic. I intentionally brought it here. So back in September 12, we had the first grid resilience symposium of the center in Salt Lake City, and then like wildfire was happening, and the whole weather on September 11, the day before, it was like a smoggy because of the smoke we had on the day. So this, but then it turns out that some of the like models that we have here, like it was developed by our partners in University of British Columbia, was actually predicting this pretty accurately, and it was showing exactly by the hour in the day the smoke that we were seeing on the air, like in that the day before the symposium. You can just click on this, you can just scan this QR code, and you will see the live map and the live forecast that they are generating every day for the center. But in addition to the weather data, we also need grid data. So the grid we see here, like we see today, and it's been like in the past like 100 some years, it's been very good. It's been delivering reliable power to us. But then there's not a lot of like measurement that we are taking from the grid in terms of the like outages and also situational awareness. So one of the things we are working on to get more data out of the grid, and more data could come in terms of the measurements that we are measuring, voltage, current, power, but also in terms of the outage data that we are getting. In a recent project with our local utility Pacific Core, we installed these like little devices called CFCIs, communicating fault current indicators, that we just basically install on the power lines. And what they do, they send information about the outage current as it passes through the lines. And this has been game changing for recovery and outage management on the grid, specifically in remote areas. When like you don't something happens, you really don't know where it has happened. Like you just have an information about the outages and where you have outages, but where the actual damage has happened, you don't know. But these things, these like devices, and using the information you collect using this from these devices and some AI algorithm, you can narrow down the area that the damage has potentially has happened. So you could actually send the crew there faster and fix the grid, and bring it back to a normal operation as soon as possible. So, but then talking about heat wave like is very complex problem. At the same time, it's increasing the demand. And the way it increases demand is just like by AC, right? So everybody is just cranking the ACs like all day, and nobody wants to let it go. Everybody has to be 74 degree or lower, right? But then on the other side, it's also impacting the rest of the grid, reducing the generation capacity. From the thermal generating units that can't operate in the normal capacity when it's hotter, but also like the solar generation. It turns out that the solar generation, it's not actually as reliable, and it cannot work as reliably when like there's a smoke on the air, when like the air is thinner because of the hot weather. So we have like been able to model the output of the solar generation. We have some models for that is showing how the atmosphere is interacting with the grid components. Specifically, we call it the land atmosphere interaction model, and then how that is impacting the generation on like the grid side. But also it's impacting the power equipment, the power lines, the power transformer. They just don't have, they can't operate in the rated capacity that they are designed to. So you see a situation that there's no immediate outage. Nothing is failing at the moment, but you have an increased demand, you have a reduced capacity of the generation and the grid component. That is putting the strain, the stress on the grid, and which is lasting for a few days. In Arizona and Utah, we just experienced some of the worst heats in the past few years. In Utah, I think this year we had the record number of days with 100+ degrees during the day. In Arizona, I think in Phoenix, we had more than 80 days of consecutive days that it was like 100+ degrees during the day. So this is like, just imagine a grid that is not designed 20 years ago, 30 years ago, 40 years ago to tolerate that much heat, let alone the generation. So this is like a problem that we are working, and also we are looking into the future. What's going to happen like 20 years from now? The utilities don't have the answer for that. But also we are looking at the impact on the communities. So one of the problems we are looking at is that, so now you have a community that is like overheated, all the houses, some of them have access to ACs, and some of them have access to better ACs, and some of them have access to better cooling system in their house, and also like insulation in their houses. So it's not the same. So some of the houses are better insulation, and some of the houses don't have that, right? So it turns out that it's like a kind of there is also an equity issue, that there are some households that don't have access to enough AC, or like their houses is not insulated well, so they get like impacted more. And when it comes to like also demographic of the age demographic, some people are impacted more by the heat, some people are impacted less. So we are also we just recently published a paper that looked at that like kind of community impacts of some of these heat wave, not only on the infrastructure, but also on the community. One of the solutions we are working at is Resilience Hub. How many of you have heard about Resilience Hubs? One, that's great. This is a new concept. We just published the paper. There's no academic paper about this, and this is the first academic paper we just published, and that's a QR code about that. It's basically, I think you've all heard about cooling centers, right? So it's kind of an extension of the cooling center, but also bringing it not only like at the community level, just go there and be cool, but also bringing to the infrastructure level. So like trying to serve many purposes, trying to serve the community, trying to serve the grid, trying to like bring many other services that are not available during disaster into one location, into one a building or like a community that could serve the community, not in terms of just like providing the power and also providing the AC, but also providing other like critical services. So as like I've just like mentioned a few examples of that, like we can increase like using Resilience Hub can help like integrate more renewable energy and provide energy flexibility, enhancing resilience, enhancing critical load backup, and also providing grid services. Specifically, a Resilience Hub can provide services, all of this during multiple modes, right? During normal operation, it just happens that maybe a few days, few weeks, a year, you have an emergency. But during normal operation, Resilience Hub also provides services that are very important for the grid and for the community. We just did an analysis on that in Salt Lake City. We identified like using the demographic data, using the like impact of heating, heat and hot weather on the grid. We identified 7 different locations that are potentially that we potentially could install a Resilience Hub in Salt Lake City to not only tackle the problem of the infrastructure, but also tackle the problem of communities that are impacted by the hot weather. I know this is taking long, so I'm going to make it short. So we develop a lot of AI data. This Wired Global Center is identified by NSF as an AI plus energy center that we just received last year. So what we do, we just have data, and we develop AI tools to make use and make sense of that data. Specifically, we have developed this tool that we call it GAPSIM, Geospatial Atmosphere Power System Interaction Model, that is basically trying to understand the interaction between those extreme weather events and the grid. And it's not as simple as just mapping those like data with the grid component. We are also looking at the interaction between those, which is like much more complex than just mapping. So, and also we are looking at like how we could modernize the operation of the grid using AI tools. We are developing enhanced outage observability and situational awareness tools, enhanced controllability of resources and grid architecture, and enabling automation and AI for grid resilience. Specifically, this is one of our patented models that we have implemented in my lab and in a pilot project with Pacific Core. This is a hierarchical AI-based controller that enables like automatic like restoration of the grid after an outage, and that's been a very successful project that we just like a $5 million project we just ran with DOE. We are developing not only like on the application side, but also theoretical side. We are also trying to see how AI and some of these methods that we are developing are predictable. We don't want to like in a physical world, we don't want like an AI solution that is not feasible, that is putting garbage out there, right? So we've developed some practices and some models that is making sure that the AI solutions are feasible, at least for the grid operation, even if they are not optimal. And one of the other topics that we just started recently working on it last year is like looking at how we can serve the needs of data, the energy requirements of AI and data centers. You all know that. I think power industry has totally missed this. One of the biggest things we do in power industry is to forecast the load. But one of the things that we miss to forecast is how fast the AI and data center energy requirements are going to grow. But then we are catching up, and some of it, not utilities are trying to do that. The industry has taken it in their hand, right? So you all have heard about this news. This is in the news every day. Amazon just invested $500 million on nuclear. Microsoft invested on that. But also one of the projects that I really like, and it's happening in our neighborhood, is geothermal. Fervo Energy is doing great. They just signed this contract with Google. And what I like about it is not just buying some power. They are developing innovative rates to actually be able to make it economically viable for everybody, for the utility, for the off-takers, and for the others. Just last month, we had this grid resilience symposium in University of Utah that I myself moderated this panel session that we brought together all the kind of parties into the same table to discuss about that. Please watch for recording of this that is coming up in our YouTube channel. But we had a representation from Google or local utility, Pacificor, plus Fervo Energy and the Utah Office of Energy Development, plus TerraPower, the nuclear solution. We need more of this innovation happening, and we need all parties to come together. It's not just the utility can make it happen. The user, the generator, the demand, and also the policymakers should make it happen together. We have the work on hydrogen on the workforce development side, and also on the innovation side that we are trying to commercialize some of the technologies. So another plug to some of the things we are doing, and thank you.
Thank you so much. We'll get moving with the next.